Right, good morning, everyone. As usual, any questions from the homework? Okay. 10.5, 45, and 43. Okay. So we start with number 43. So number 43. Right. So we have the following series. So we have the following sum. K square plus 2k plus 1 over 3k squared plus 1. And the k go from 1 to infinity. Right? So this is the series that I'm working with. So sigma k squared plus 2k plus 1 over 3k squared. And the question is, does it converge or diverge? So we're adding those terms, very messed up terms, but it is what it is. So these are my AK. These are the term I'm interested in. Plus 1 over 3k squared plus 1. So I'm adding those type of terms, and the question is, okay, if I add those terms, will eventually the series converge or it will diverge, and how do we know? All right, ideas. Ideas. How can which test can I use?
Could we use divergence test first? The if a.
Yes, absolutely correct. Watch carefully. Watch carefully the terms. When k goes to, usually, you know, the which test to use is like integration technique. You have to look at the terms and ask yourself, you know, which test will do. So it's really going to depend on the type of terms we have. But most of the time, it will be helpful that once you have the term, the general term, just glance at it and ask yourself, when k is large, what happened to those terms? So in this case, particularly, if we look at the terms, when k goes to infinity, limit of the AK, because we should see something. When you look at this, you should start seeing stuff. That's k squared plus 2k plus 1 over 3k squared plus 1. So when k goes to infinity, what happened to those terms? They become close to what? Anybody?
It's infinity over infinity.
Yeah, infinity over infinity. So we're going to compute it. But can anybody tell me immediately what's the limit going to be?
1 over 3.
It's going to be 1 over 3. Because the top, it's k squared plus 2k plus k. So intuitively, the top is going to be totally dominated by k squared. So when k is large, those terms will be very small relatively to k squared. The denominator is going to be dominated by 3k squared. Because when k is large, you know, 1 can be totally neglected. So the whole thing will behave like 1 over 3. So eventually the limit will have to be 1 over 3. And that's why you can kind of glance at it and say, you know, the limit is not going to be 0. Okay, but we're definitely going to compute it algebraically, but our intuition should start kicking. So the numerator is going to be dominated by k squared. It means when k is large, if you take k to be a million, this is going to be really small compared to k squared. The same thing in the denominator. So eventually the ratio is going to be a third. Now let's do it algebraically. We divide by k squared, both sides. I will have 1, 2 over k, 1 over k squared. It's easier than L'Hopital's rule, plus 1 over k squared. So when k goes to infinity, this goes to 0, goes to 0, goes to 0. This is equal 1 over 3. All right, very good. What does it mean?
Doesn't it just mean that like it can converge or diverge? Because wait, never mind.
That's all right. Anybody else? The terms, when k is large, it means when I'm start adding those terms, that's really the picture. So instead of writing them, I'm going to call them A1, A2, A3. So where A1 is 1 plus 1 plus 2 plus 1, it means it's 4 over 4, 2. I plug in 2 in it. So instead of doing this, if I'm plugging here the terms, those terms are going to come close to a third, to a third, to a third. What does it mean? What can we say? Exactly, what can we say about the series immediately? We're going to be adding eventually what? A third, plus a third, plus a third, plus a
It
third.
diverges.
Has to diverge. It has to diverge because eventually that's what we are adding. So the limit that's different from 0, the divergence test tells us immediately it will diverge. So the series will diverge by the nth divergence test.
On the quiz, a question: do we have to put, because of the divergence test, it diverges, or do we just put
Yes.
like it diverges?
You have to, no, you will have to write very clearly which test you're using, and you have to write very clearly why the test you're using is working. I mean, you have to write exactly the way I'm doing it, by the divergence test. You have to explain clearly which test you're using and why it's applicable. I mean, why you can use the test you're using by the divergence test. All right. So that's really what's happening. We're done. I mean, if you add up those terms, you're definitely going to go to infinity because intuitively, as I said, eventually you're adding plus 1/3, plus 1/3, plus 1/3. This is already 1. And then you're keeping a third plus a third plus a third. That's another one. A third plus a third plus a third. So you keep adding and adding. Eventually, you're going to blow it. The sum will blow up. Okay, so that was a good one. We look at 45. Ah. Okay. K equal 3 to infinity. Okay, that's a hard one. And over ln of k. Okay, that's a hard one. Anybody has any hint how to do that? So what we know so far is the divergence test, integral test, limit comparison, and comparison. These are the tests that we've seen so far. So AK, so I always write the term in front, I put it in front of me to see, which test, what can I do? So I examine the term, what type of terms I have. Okay, anybody? First, when k goes to infinity, 1 over ln of k go to 0. So no conclusion because the terms are becoming small. The question is, are they becoming very small or not small enough? And that's what the tests are telling us. Anybody has any idea?
Would it be divergence test?
How? Tell me how. If we, okay, I'm going to put parentheses. When k goes to infinity, that's the divergence. 1 over ln of k. What's the limit? What happened to that when k goes to infinity?
0.
0, because ln of k goes to infinity. 1 over that's equal to 0. So the divergence test is inconclusive. Okay, so inconclusive.
Can you use a comparison test?
Comparison test. That's a very good idea. Compare it with what? I know this problem is hard. I haven't done it, but like it, but that's why I assigned it. So we learn it.
Well, could you make like AK 1 over ln k and BK 1 over k and then
Okay.
divide?
That will be the limit comparison.
Oh, okay. Yeah.
We're
so
going to
only-
use the comparison. We're going to use the comparison test itself without a limit. Okay, so something that we should know, that's why I assigned this problem, is the following, that okay, ln of k is always less than k. Okay, so all of you want to compare it to that. So I'm going to put it in a very clear way. ln of k is less than k. It means, what do I mean by that? ln of 2 is less than 2. ln of 3 is less than 3. That's really what I mean. ln of 4 is less than 4. So graphically, if we take the graph and we graph the following, we graph ln of x, that's ln of x, and we graph the function y equal to x. X is always above the ln. So those how they are graphically. So no matter what x is, the ln of x is always less than x. Okay, that's a fact that we should know. And that's why I give you this problem. So the ln of k is always less than k. So ln of 100, which is, as you guys remember, we computed those numbers, is actually way smaller than 100. And so on and so forth. Okay, so this means that. So this is a fact that now that you know, you can use all the time. So this means that when I flip them, 1 over k is less than 1 over ln of k. Okay, so 1 over k is less than. So I'm going to use the comparison test, not the limit comparison test. So now we have the following. We take bk, since I called those ak, so we're going to take bk to be 1 over k. And now we have the following. Everything is positive, means the bk is less than the ak, and everything is positive. Now, the smallest series, and remember yesterday I told you memorize it as smaller versus larger, not as AK, BK, because I can change which one AK and which one is BK. The smaller one, the series sigma BK diverges, since sigma BK is sigma 1 over K, which is a P series with P equal to 1. So that's why it diverges. That's the harmonic series. Hence, by the comparison test, not the limit, usually other books call it the ordinary comparison. So this book call it, by the comparison test, the series sigma AK, which is the larger one, means sigma 1 over ln of k, basically the larger one will diverge as well. Okay.
I have a question.
Yeah, of course.
When you usually write down the rule for comparison tests, and it's usually just one way. It's like if AK converges and BK diverges, and if BK converges and AK diverges, can it be the other way around as well? So can it be BK converge if BK converges and AK converges, and AK diverges and BK diverges?
Okay. So if sigma BK converge in this setting, Sigma AK, I have no clue. And I'm going to ask you to give me examples. If the smaller one converge, I have no idea what did happen with the bigger one. It may converge or diverge. I don't know if I'm answering your question.
Oh, okay. So it can't go the other way around because, okay.
Because it's less than. So if this one, if you add those terms, think about addition. You add the smaller term, you get close to a finite number. It doesn't mean when you add the larger term, you're going to get close to a finite number. And once I finish answering your question, I'm going to ask you to give me examples. Okay?
Okay, so AK has to be the one that's that has to be the one that converges because it's the bigger number.
Right. Yeah. If this one, in this setting, in this names, if this one converges, the larger one, the smaller one is always less than it. So it cannot blow up by itself. It will have to converge. Am I answering your question?
Yes.
Okay. If the smallest one diverge, if you add the small number, you go to infinity. When you add the larger numbers, of course they will go to infinity. So it's not, they do not behave the same way. Absolutely not. And as I said, once we're done with those, I will ask you questions. Hopefully that will clarify well your questions. Now we'll do number 50. So for this one, I like this problem. Number 50. Okay. And what is it about? Okay, sigma k equal 2 to infinity of 5 ln of k over k. And again, that's the series converge or diverge. So here my AK equal 5 ln of k over k. So now parentheses, when k goes to infinity, what happened to the AK? Just out of curiosity. Back to you.
Isn't it gonna go to 0 because since
Absolutely.
x is always larger than ln x,
Right,
the
way
numerator is gonna
larger,
grow
way larger. So this is, the intuition is gonna be to 0. Now, how can you do it mathematically? Because on your exam, on your quizzes, I want the algebraic reasoning. So I want intuitively why it's happening, go to 0. You're absolutely right, because ln of k goes to infinity way slower than k. That's the intuition. But I always want the mathematical reasoning. How can I prove it mathematically? Which test do you want to use? Come on, guys, that's a simple one.
Would it be divergence?
No, wait a second. No, I'm asking why this limit is equal to 0. How can you convince me this is 0?
You have to use L'Hopital's rule.
L'Hopital's rule, yeah. That's 5. Derivative of that is 1 over k. Derivative of k is 1. When k goes to infinity, this goes to 0. So no conclusion. So there is no divergence test in the picture at all. Since the terms are becoming small, then the series can go both ways. So no conclusion from divergence test. All right, so that's totally out of the picture. So now we need something else to decide whether it converges or diverges. Which test would you guys like to use to decide whether it converges or diverges?
Maybe the integral test.
Absolutely, the integral test. Okay, this is a scenario where the integral test is the way to go, because comparison, I don't know, limit comparison, I don't know what to compare it with. Because when k is large, ln of k is less than n of k, this is k. So nothing really I can do about it. Now, comparison, now I did tell you that ln of k is less than k. But this means that this is less than k over k, which is 1. Again, that's telling me nothing. So this is a scenario which is actually basically telling you, This is the integral test. This is absolutely the integral test. So we have to take the function f of x equal 5 times ln of x over x, and we're going to proceed. So we take the integral, and this time it's from 2 to infinity of 5 ln of x over x dx. Okay. So this is 5. I don't have to worry about it. That's the limit as t goes to infinity of the integral from 2 to t of ln of x over x dx. Okay, and now I have to compute this limit. So I evaluate the indefinite integral, and then I go back to my limit. Okay, that's a typical one. That's my u is ln of x, my du. So this is nothing more than integral of u du, which is a half u squared. It means a half ln of x squared. Okay. Now I go back to my integral and I will proceed. So this integral, this is equal to the limit as t goes to infinity of, so 5, I can keep it here. Antiderivative, so it's 1/2 ln of x evaluated between 2 and t. So that's 5 times the limit as t goes to infinity of, I can basically factor out the ln. I will have the ln of t squared minus the ln of 2 squared. Now, when t goes to infinity, the ln of t, this term right here, this is definitely goes to infinity, and this whole thing blows up. So now by the integral test, since the integral diverges, the series itself will diverge. End of the problem. Okay, so this is definitely screaming integral test. There is nothing else we can do about. Okay, so those are those examples, that those problems that you guys asked about. Actually, basically, we saw all the tests that we've learned so far. So we saw whenever you have a series, the first problem, we actually look at the term. Usually we glance at them, okay? And you ask yourself, what happened when k is large? Just by glancing a lot of time. You don't have to do all the math unless you realize that it's not zero. So you glance and say, you know, what happened when k goes to infinity? If you glance at those terms, you say, you know, the limit is 1/3, therefore it's gonna diverge. So you just glance at them. Then once you realize it's 1/3, then you can do it, you do it algebraically, you convince yourself you are correct. And then if the limit is not 0, we're done, the series diverge. Then we had other situation where we had a series like this, 1 over ln of k, the terms do go to 0, so no conclusion. And then the question was which test to use. So we go through the test in our mind. Okay, limit comparison, we have no idea what to compare it with because it's ln of k. Integral, if you know how to integrate this, I'll give you 100 on the final. So I don't think you can integrate that. So that's out of the picture as well. Then, okay, I have to interfere and I tell you this is really what's happening. We have to use the actual comparison test and we proceeded. The last example was an integral that's basically screaming integral test. A series that's screaming integral test, because when I look at this one, I know I can integrate it very easily. Okay. So what we're going to move to, of course, not today, all the tests that we've worked with are valid as long as the terms are positive. They are not valid when the terms become negative and positive, when they start changing sign. What we're gonna move to is what happened when the series is allowed to take sometimes positive and sometimes negative value. And that's what we will be taking on when we come back on Monday. All right, for the last 5 minutes before we take the quiz, I want to ask you the following question. I want you to give me example of two series. It's easy, it's not hard. So give example of two series, sigma AK and sigma BK, such that. So the first example I want is the following. AK, everything is positive, less than BK. I want sigma BK diverges and sigma AK converges. Okay. Get going. So I want example of two series such that the smaller one converge, the larger one diverge. And this helped one of your classmates who's asking me those questions. So whoever has an answer can put them on chat. Okay, Wyatt is giving me AK to be. Which one is AK, Wyatt? Wyatt, which one you picked it to be the AK?
Sorry, 1 second. That would be AK is the smaller one.
Which one?
That would be 1 over e to the x.
So BK is 1 over square root of K. All right? Okay, so I mean, there are easier series, way, way easier. Can anybody think of an easier one? If not, I'll go back to that because that's a correct example.
I
Everybody
got
think of very easy one. And
I got
go ahead.
I got BK equals 1 over ln K squared.
ln.
And AK is equal to 1 over K squared.
Oh, that's not bad also. But why this one diverged? This is problematic.
Oh, I said ln K squared just because, I mean, if that
You have to show me why it diverges. It's going to be hard. Because if you pick it this, you have to tell me why this one diverges. We showed 1 over sigma 1 over ln of K diverge. Why sigma 1 over ln of K square diverge? I don't know. Are you with me?
Yeah, I know what you mean.
Yeah, this is hard. And I don't think it's correct also. So I'm going to scratch this. Okay, Elizabeth is pitching in. She's giving me BK to be 1 over K. Okay, so I have two good examples. This is a very good example, and this is better. This is better. This one, as I said, that has issue. I cannot accept it. All right, because this is a very good example. Let's watch very carefully. 1 over k squared is definitely less than 1 over k. Absolutely correct, because k squared is larger. So the denominator is larger, 1 over it is going to be less than 1 over k. The smallest series, sigma 1 over k squared, definitely converge. The larger 1 over k diverges. Okay, absolutely correct. The one that Wyatt took is also correct. 1 over square root of 1 over e to the k is way, way smaller than 1 over square root of k, because square root of k is smaller. It means 1 over ek will become less than that because the denominator is larger. This one converge, diverge. This one converge because it's geometric series with ratio 1 over e. So both examples work. All right. I think quiz time. Good luck and get going.